Homework 3, problem 8. Find the work to bring the charge plus q in from infinity into the corner of the following square, and then find the work to assemble all 4 charges into the system. First thing that we're going to go for is we're going to do a little bit of proof that work we know is the path integral of dl dot force, but force for us is just going to be q times the electric field. And it's actually going to be minus q because it's us pushing, so we're pushing against the force felt by the particle. So there's where the minus comes from. So plugging this in, this is going to be minus q times the integral along some path, this is the path gamma, of dl dot e. But I know the integral of dl dot e is just the potential energy. So this is minus q times the potential energy of where it eventually sits. So that's all we have to do to evaluate part A. So part A is just minus q times the potential energy for each one of the 3 charges here. If we label each distance A, then this distance here is of course square root of 2 times A. So the potentials for each one of these is going to be the same thing twice. So twice minus q over 4 pi epsilon naught 1 over A, then plus positive q over 4 pi epsilon naught over the square root of 2a. Oops, minus goes here, and with the minus, this is the potential V. So that's positive. And so that's it for A. So this A, if we simplify this a bit, the work done is going to be q squared over 4 pi epsilon naught A, and then we're going to get 2 plus 1 over the square root of 2, or minus 2 plus 1 over the square root of 2. And that is the work it takes to assemble that charge. For part B, we're going to use another trick, which is if we assemble them one by one, we could write down that the work it's going to take to assemble the ith charge is going to be qi times the sum of j less than I of the potential due to the jth charge of the ith charge sitting at position Ri. And so if we just assemble these, then we'll get up to what we need. The trick here is, here we count from j to I. If we simply double count and count from, so this would be like I up to 4, and this would be j less than I. If we count from j up to 4, and we simply say that j cannot equal to I, then we need a 1/2 here. Well, if we put a 1/2 there, then we recognize that for each one of these charges we're going to have the same energy, and we've already done that. That's the work we did in part A. And so we're going to have 1/2 times the sum for all 4 charges, so that's just twice the work we did for A. So for part B, it's just going to be twice what we got here. So this will be 2 times q squared over 4 pi epsilon naught A minus 2 plus 1 over the square root of 2. And that's the work done to assemble those charges.